So in order to find arc length, we need two pieces of information. You need an arc measure and the circumference of the circle. Because we already determined an arc is a piece of the circle. So if we want its length, which is it's a length measurement, it's not an angle, okay? It's a fraction of your circle. It's a portion of it. So the easiest way to think of arc length is that it is a fraction of the circumference of the circle. If you can remember that in general terms, then we can find what we need. Okay, I didn't do this earlier, but I'll start out a little easier on you guys. Okay, so the fraction part, if I wanted to find the length of AB, the fraction part would be to look at it and go, well, AB is 90 degrees, and 90 degrees happens to be a fourth of my circle, right? So my arc length should be a fourth of my circumference. Okay, that's the general idea. Now, you're not always going to have angles as easy as 90 degrees where you can go, oh yeah, that's a fourth. They're not all 90 degrees. But what you're going to do, the fraction part, is the measure of your arc out of 360 degrees. So that's going to tell us what fraction of the circle we're dealing with, times the circumference, which we'll just list right now as pi d. So here's the nice thing. The fraction of my circle is 90 out of 360. But if you already know, some of them are more easily simplified than others. If you already know that 90 out of 360 is a fourth, then by all means use a fourth. That's what it ultimately is. And the less simplifying you have to do, the better. So it's going to be 1/4 of pi times the diameter. The diameter is 24. Okay, so with this, you could say, well, a fourth of 24 is 6, right? So that would be 6 pi, we'll call this inches. 6 pi inches would be that part, that length. Now I'm going to give you one that's a little more complicated because we're not putting things in decimal form. We're keeping them in terms of pi, so also fraction form if it doesn't come out to a nice whole number. So the next one we're going to look at we're going to use the same radius for now. So you can do a little comparison. So here, for the length of AB, instead of 90 out of 360, we're going to do 80 out of 360 times the circumference, which is still same radius, so it's still 24 pi. Okay, now this is going to involve a little simplifying. You know, be nice to yourself. I would not multiply 80 and 24 and then go to simplify. When you have a product, I would extend this. 24 pi is on top with 80. So then you can kind of look and say, all right, 24 and 30, well, first of all, the 80 and the 360, you can knock off those 10s. Yes? can always get rid of a 0 top and bottom. 24 and 36 share a factor of 12. So that is what I would do next. Divide 24 by 12 and you get 2. And divide 36 by 12 and you get 3. And it makes it a little messy, but if you're following what I'm doing, then I can do 8 times 2, right? Is 16 with the pi there and 3 on the bottom. Now, if you insist on multiplying 80 times 24 and simplifying that over 360, knock yourselves out. But I think it's easier to take your smaller numbers and see what you can do with what's on the bottom. Okay, that would be your answer, also in inches. Okay, so we're going to do one that is a major arc. So in this case, you're finding the length of ADB, which is all of that. So again, in general terms, you're finding a fraction of the circumference. So what would your fraction be for starters? Yes. Okay. That's where you want to be careful, because this is 150, but that's going to be bigger than 150. So you do 360, which is the entire circle, minus 150, so it'd be 210 degrees. So you have 210 over 360. And our circumference is what? Pi times diameter. What's my diameter? Diameter is 36, so 36 times pi. Okay, so again, I would not multiply these. That's going to be on the top anyways. So you can knock off those zeros, right? And do you notice you've got 36 and 36? That's a bonus. So your 36s cancel. So it's just 21 pi centimeters. Now, in all honesty, I mean, if you had checked with your calculator and did 210 by 36 divided by 360, you're going to get 21. But it's a gamble. Sometimes you'll get a whole number, sometimes you won't, and then you're going to have to go back and simplify anyways. So if you see some things that are easy to simplify, you know, you can probably have it simplified in the time it's going to take you to punch it into the calculator anyways. All right. Okay, so we're going to do 2 problems out of your homework. One of them is a word problem. And I'm helping you with this one because I remember when I first learned these long ago, I was like, what? What do they mean, revelations? So I'm going to help you through it. The wheel of an adult's bicycle has a diameter of 26. Inches. Okay. The wheel of a child's bicycle has a diameter of 18 inches. to the nearest inch, how much farther does the larger bicycle wheel travel in one revolution than the smaller? Well, if you really think about what they're talking about, one revolution, if you had a chalk mark on your tire and it goes around once, that's just circumference, right? Okay, well, to figure out how much more circumference one has than the other, you're just going to do the circumference of the adult tire and the circumference of the child's tire and take the difference. Okay. Now, this is why I want you to, make things easy on yourself and don't multiply by pi. This is one of the cases where you want to leave your answer in terms of pi, because then we can treat it like a variable. So here, what is my circumference? 26 pi. And my circumference here is 18 pi. And the difference, you don't need to pick up your calculator. If pi were a variable, you would do 26 pi minus 18 pi, right? And you would get 8 pi. And then you can pick up your calculator and do 8 times pi, and it's to the nearest inch. And I believe that came out to 25 inches rounded. Okay, so you have control of the rounding at the very end. We didn't have to round this and round that and maybe round again. Okay, and we got a pretty close answer. So whenever you have the opportunity to leave things in terms of pi because something else is going to be in terms of pi, leave it. That way you use it like a variable and then round later. Okay, so last one, 39. Okay, you need to be aware in that section they're asking you to find the arc length of the red portion of the circle. If you don't read the directions, you're going to be like, what am I finding these arc length of? It's the red part. Sometimes hard to see, you have to look close. In this problem, this is what you're finding the arc length of. Okay, so arc length again, you need the fraction of your circumference. So for the fraction, I need the arc measure. What is the arc measure of this one here? Anyone? Bueller? Nope. Nope, the arc measure for this. Arc measure. What degrees? 25 degrees. Why is it 25 degrees? Right, and what are these things called right here? Long time since first semester. Vertical angles, right? Vertical angles are congruent, so if that's 25, then this is 25, which makes that 25, which makes that 25. So it's always nice when we have those things from the beginning of the year that pop back in, but this is also 25. So you have 25 over 360 times 18 pi. So I'll extend that because I don't know if you're noticing, but 18 does go into 36 twice. So that would make that 20, right? And then you can do 25 over 20. Simplify that. You have 5 on top, 4 on the bottom. So that would be 5 pi over 4 meters.